Yeah, my name's Mark Bachmann. I manage Glenelg Trust. We're a not-for-profit organisation that operates largely between Adelaide and Melbourne in the NRM region situated in that zone. And if people know that part of the world, it probably comes as no surprise that wetlands, we've chosen to make a real thematic focus of our organisation. Been very busy over the last 6 years since we started, particularly in the southeast and western Victoria, but a few years ago we were invited to become involved in looking at some of the issues surrounding hydrology of fluorio swamps, which for people that are based in Adelaide will be familiar with these communities on the fluorio which are nationally threatened. And I guess of interest to us was the fact that hydrology hadn't, although people were aware that it was an issue, it hadn't been looked at perhaps as closely as it could have. Probably the key thing to mention too, and a reason I'm really pleased to be talking this session, is that restoration is a real focus of our organisation, and particularly from a scientific and experimental point of view, trying to unleash self-sustaining solutions, I guess would be the way I would see it, in terms of the sorts of things that really inspire us and that we're passionate about. Before I get started on the site, I just thought I'd talk a little bit about the science of water and wetlands and the sort of issues that influence our wetlands and their hydrology. Now, there's been a lot of talk about climate, and this goes up first, but it's often the one that we've probably got the least capacity to do anything about in the short term, but we can't ignore it. This is very real. Development pressures, that's obvious enough. Plantation establishment, there's multiple ways you can affect the hydrology of a wetland, including interception of recharge and influence on aquifers. Irrigated agriculture, direct extraction, these are all significant influences. And last but not least, physical artificial drainage, which isn't mentioned last because it's not significant. It's actually the most significant, and it's also the most significant from a restoration point of view because it's the one that we have the most capacity to deal with here and now as a way of buffering against some of those other influences which can't be dealt with quickly. Some of them take policy to change over a long time, or you go outside and do a rain dance in the case of climate change and hope for the best. The reason this is exciting to us, and I hope people will see the value in this by the end of this talk, is that wetland restoration has the capacity through just adding water to produce self-sustaining outcomes. And this is the thing that we've been able to demonstrate a number of times over in different situations. An example I'll give you before we talk specifically about Glenshera Swamp is down in the southeast. This is a property that, as well as working with people on other people's land, public land, private land, where we've done most of our restoration work, occasionally places come along where the only way to achieve an outcome is for us to try and raise the funds to secure a site. And as you'll see, Mount Burr Swamp being situated next to a large wetland reserve in the southeast, one of the most significant reserves in the state in terms of floristic diversity. The opportunity came along for us to try and go about securing this site. It took 5 years of my life, but a couple of years ago we finally got there. That's where it's situated. One of the reasons this property stood out, despite the fact that if you went out there and had a look at it a couple of years ago, you would have seen lots of drains, those purple lines, mixed agricultural use, lots of impacts. But underneath that, and the sort of lens that we like to see the landscape through, is restoration potential. And that LiDAR image, which excuse the lines that run through it, that's just a mismatch of where the tiles have been joined, but you'll notice the depressions and the drainage network. Great opportunity to remedy that through manipulating the way that water flows out of this site. And to give you an idea of how simple that could be, so 50 years of artificial drainage, half a day with a team of volunteers to put in a sandbag structure as a trial initially, when around the time we purchased the site. And from autumn 2016, with the trial structure in place through spring, and a year later, you'll see the same time of year, the sort of influence we've been able to have on that site. And out there is a bed of triglocan water ribbons, spontaneous recovery of that community, and now host to a couple of nationally threatened species populations, dwarf galaxus and growling grass frogs or southern bell frogs. This is a view of the same area. Whoops, sorry. I hit the wrong button. Click that one again. This is the view of the same area from the air. Again, these images are about a year apart before restoration, and you'll see the drainage network there, and this is the same time of year a year later with the sandbag structure in the drain and the recovery of that bed of triglycerin in the wetland. So just add water. Self-sustaining outcomes. Wetlands give us this, and if you choose your site correctly and understand hydrology so that you've got the tools available, then you can actually trigger this response. Terrestrial revegetation, we've still got lots of that to do out there. It's a complicated property. It's going to take a number of years to unfold, but there are some really early gains you can get by working with water. Right, so the reason, throwing that in, it's interesting, in the Flurio, you know, people think about the state getting drier as you come north, which it does, but of course, people don't necessarily think about, I mean, I grew up in Adelaide, didn't really think about wetlands being a big feature in this part of the world, but you don't have to go very far south when you get onto the Flurio Peninsula, and it turns out, this is part of a study we did in the Tukayuta catchment, by analysing aerial photography, that the amount of artificial drainage not far from here on the Flurio Peninsula is really significant, and the effect of it has been quite substantial on not just on local groundwater aquifers, but on the ecology of the systems that rely on that. So Glenshera Swamp, which many people will be familiar, is one of the most significant sites of nationally threatened Flurio swamp community in the Flurio, one of the largest sites. It turns out that it's just west of Mount Compass, for those people that don't know specifically where I'm talking about, just south of Adelaide. We're fortunate this area wasn't modified site, so we can see here some very, very early evidence of drainage in 1949, but the swamp was largely intact. This is a view of the swamp as it appeared before we began working out there, and interestingly, the swamp is still there, but unless you know what to look for, you won't necessarily see the evidence of drainage until you go looking for it. It turns out there's a network of drains like that through the swamp that have been put in there over the years by the farmers seeking to remove water to make it more viable for grazing. And I'll mention at this point that I gave a talk about this topic a couple of years ago, and I think that's on the NRM website. So if you want to understand more about the background of how we got to the next steps, then you can go back and view that talk rather than me giving the same talk again. From here I'm going to talk about what we've done next. So really quick overview of what we analysed at this site. We looked at the way water was moving through the site now, how it interacts with these artificial drains, and that led to the development of a report that outlined what sort of actions we could take, and the goals that were underpinning the idea of the sorts of actions we would take were that we wanted to significantly slow the movement of water through the site. Sounds sensible enough for a peat wetland system. Increase residence time. We'd like to see positive change in trajectory of some ecological measures. And we're aware that a lot of people were watching. This is a site that a lot of people care about, so you have to make sure that you come about solving these issues in a way that people will be comfortable with. What that led to was 6 actions that, you know, we try to make this stuff as simple as for people to understand as possible, but the site is quite complex. We've got inflowing surface flows from a creek on the right-hand side that were being cut off by the artificial drain at the top of the site, and a network of drains through the bed of the swamp, and also some changes around the slope. We got funding not long after gave the talk 2 years ago, the plan was in place. 12 months later we got funding to implement works, 4 of those actions, both on and off park. And the sorts of things we've done dealing with the inflow surface flows to redirect them back to the swamp rather than bypassing the swamp, which was one of the issues with that artificial drainage work. You'll notice in the LiDAR image there, the bypass drain actually cut meanders in the creek. And what we've done last year, we constructed a series of these trial structures to lift the water back out of the drain and onto its original meandering flow path and floodplain. That's a before image. Also putting a cut through the spoil bank. When you dig a drain, you put dirt next to it. That means that you have to breach that to be able to get the flows through. And that's what it looked like a few months later when the site flowed last year. This is a reverse view just to show you the step down, the difference in that elevation. So we have to lift the water up by pooling it behind the structure and then down the meandering flow path. Second structure, I'll show a couple of examples. This is where the water comes back out of the meander and has to cross back over that drain again. And again, by lifting the levels in the drain, we're able to allow the water to continue along its meanders. This means we've seen change in the in-stream ecology and response of plants out of that drain that mean that we've increased the wet footprint of this system, if that makes sense. As you continue down, this is a spot where we've been, where we put the main structure in that diverts flows back towards the swamp. This is the sort of process involved in building one of these structures, bedding it in and including the team that helps put it in place. There's a bit of physical labour involved, and this just shows you the water backing up behind it. This is that same point from another direction, showing you the breach in the spoil bank and how flows have been directed towards the swamp. Off park, we were also able to backfill network of drains using the LiDAR imagery, and you'll see the network of drains here. These sites are more complicated in that you can't put a single control point in like at Mount Burr Swamp I showed you earlier and affect the whole swamp, because the whole system slopes. It's in a valley. The peat has formed along a sloping system. So the way to fix this was to actually backfill the entire network of drains. And we've got a couple of regulation points that allow us to still maintain service for drainage outside of our restoration zone. So this is before and after. It's the network of drains before, and you'll see where the excavator has been in there operating, backfilling, knitting the surface back together. And we've got these couple of regulation points where we have to manage flows back down into the artificial drains, because obviously you've got now a steep change in elevation of water from the saturated surface back down into the flowing drain. And just to show you how quickly these saturated systems, the water backs up behind what you do, this was happening within hours of the works occurring. And so that's the first spillway. And I'll show you this image just upstream of the spillway. This is what we want to see. That's all terrestrial vegetation, bracken and blackberry on your right. It's been killed by that resaturation of the peat. And on the left, you'll see the wetland flora is really bouncing back. Water where it hasn't been at the surface for 60, 70 years, even though the flora were hanging on. And this is the sort of thing you see in the footprint where we've been removing material from where the spoil banks were, spontaneous recovery of tea tree and carex and various other things just bouncing back because the seed bank's there waiting to be unleashed. The second spillway, just showing you the upstream view of this. There was a trickle down the bottom of this drain 12 months ago. We backfilled it, put in another spillway, and this is the view 12 months later, the same time of year as that image. This was just taken the other day. Just look how green that view is again. And the change in flora in the background. So a phalaris-dominated system. We've got the sedges and rushes that were hanging on and now bouncing back. So to summarise, wrap up, I guess one of the things that really was exciting about this site was that to do it properly, when the department first approached us about becoming involved, we said, do you mind if we don't just look at the park? Because the neighbouring peat is part of the equation, and thankfully everyone was open to it. The neighbours have been fantastic, and we've been able to work across boundaries. Water forces you to think that way, and some really great outcomes have resulted. So hopefully we see more of this sort of thing on the Fleurieu in the future. If you're interested in the work, there's PDFs available on our website, or some of these reports are at our spot in the tent if you're interested to obtain a copy. And lots of thank yous, but we're really grateful to have been invited to be part of this project with the range of other organisations that are involved, and such goodwill, and people really want to try and do their best for these ecosystems, and we've been grateful to be part of it. So thanks very much.